Hey guys, welcome to the new unit. Unit 7B, functions. And I hope you notice that we're in the same packet that inequalities was in. This is just page 14, but I hope you notice that the word fun in functions is in bold. Okay, so the first we're going to do, again, we're on page 14. You don't really have to put your name on here, but if you wanted to, because again, this is in the middle of the Unit 7 packet. We're not getting a new packet. This is just right after inequalities on, of course, as I said before, page 14. So if you flip this page, you're going to see a bunch of different vocabulary words for all the various words that we'll see during the unit. There's a second page of those words that we'll see here. But what we're going to focus on today is an introduction to functions, a functions intro. So what a function is, it's showing a relationship between numbers. And it's similar to some things we've done before, like ratios, which we did in Unit 2. And there will also be equations involved in functions. So again, a function is showing a connection or a relationship between two amounts. So we're going to just do an introduction here, just to kind of see the connection between the words of a ratio or a function, how to write a function as a ratio, as a table, as a graph, and as an equation. So for this first example, it says, for every boy on the soccer team, there are 4 girls. For every boy on the soccer team, there are 4 girls. So what we can do with that is write a ratio of boys to girls. Now, a ratio is kind of like a fraction. It's comparing two amounts, like a fraction. So for every 1 boy, there are 4 girls. For every 1 boy, there are 4 girls. So that's a ratio. Now, in our table here, we have 2 amounts. One is boys, and we're going to use B to represent boys. And the other amount is girls, and we'll use G to represent girls. So I'm going back to the words here. It says, for every boy on the soccer team, there are 4 girls. So I'm just going to zoom in a little bit. If there's 1 boy on the team, there'd be 4 girls. So you can see the connection between boys and girls. For every 1 boy there are 4 girls. 2 boys, well, for each boy there are 4 girls. So if there's 2 boys, there would be 8 girls. So as one changes, the other changes too. There's a connection between them. 3 boys, well, that will give us 12 girls. And 4 boys, that would give us 16 girls. So again, as the boys increased, so did the number of girls. So now, we haven't really done this so much this year, but we're going to graph it. We're going to use a little coordinate plane, a little graph. So on the bottom here, we'll say this is the number of boys. And on the side here, we'll say this is the number of girls. So if there's only one boy on the graph, there's going to be 4 girls. So this point on the coordinate plane will show, well, if there's 1 boy, there's 4 girls. Now, if there are 2 boys, there are going to be 8 girls. We got that right from the chart. 2 boys, 8 girls. So 2 boys is going to give us 8 girls. Now, that's as far as we can go, really, with this graph, because if there are 3 boys, there are 12 girls. And if you look here, 3, if we try to go up to 12, we can't. It would kind of be up here somewhere. But that's how you can show a function on a graph. Again, a function is a relationship or a connection between 2 amounts. The last thing we're going to do here is kind of using our table, using our graph, looking at our ratio and our words, we're going to write an equation. So I'm going to show the connection between boys, which we're going to use B for boys, and girls. Now, these are not equal. The number of boys on the team is not equal to the number of girls. In order to get the number of girls on the team, how could we go from boys to girls? So if you look here, boys starts at 1, ends up at 4 girls. 2 boys, 8 girls. 3 boys, 12 girls. So it seems like if you multiply the number of boys by 4, you get the number of girls. So you kind of see the connection here. So 1 times 4 will give you 4. 2 times 4 will give you 8. 3 times 4 will give you 12. 4 times 4 will give you 16. So if we take B, which is the number of boys, and multiply it by 4, it's going to equal the number of girls. So this equation shows the connection between the two amounts. Boys, the number of boys times 4 equals the number of girls. Again, this is just an example of a function, what a function might look like, a connection or relationship between two amounts. All right, now, this time we start with the table. See here we have cups of flour, number of eggs. And if you look at the chart here, we have 2 cups of flour for 4 eggs, 3 cups of flour, 6 eggs, 4 cups of flour, 8. So let's write some words to show what's happening here. Looks like for every 2 cups of flour, there are 4 eggs. So looking at the table, those are the words we could write. Now, if we think about a ratio, again, a ratio is a comparison of two amounts. So we can kind of put like the flour on top and then the eggs on the bottom. Okay. For every 2 cups of flour, there are 4 eggs. 2 cups of flour, 4 eggs. That ratio shows for every 2 cups of flour, there are 4 eggs. Now we can actually simplify this by dividing the 4 and the 2 by 2. Divide by 2 on the top and bottom. So this shows, actually, we can say it like this. For every 1 cup of flour that we use to make something, maybe this is a cake, there are 2 eggs. All right, so again, we can see a connection between flour and eggs. There's like double the number of eggs as there is flour. So now we can use a graph to show this connection sort of as a picture. So the bottom is going to be flour, cups of flour. Okay, and then the other axis is going to be eggs. So if we have 0 cups of flour, we'd have 0 eggs. So I'm actually going to put a point right there. 0, that's 0, 0. If we have 1 cup of flour, and you can see that in the ratio here, 1 cup of flour, we'd have 2 eggs. 1 cup of flour, 2 eggs. Looking at the table, if we have 2 cups of flour, we'd have 4 eggs. Flour, eggs. 3 cups of flour, 6 eggs. 4 cups of flour, going all the way up to 8. 8 eggs. 5 cups of flour, and flour again is on the bottom axis. It's called the x-axis here. 10. So look here. It kind of looks like a line almost. Kind of like a diagonal line there. So here's how this is going to look as an equation. We have cups of flour, which it looks like we're going to use C for that, and we have eggs. There's a connection between these two. How do we get, though, from flour to eggs? It looks like 2 to 4, 3 to 6, 4 to 8, 5 to 10. Looks like we can multiply by 2 for each one of these. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. So the connection is, if we have cups and we multiply the number of cups of flour by 2, you get the number of eggs. So like, let's say I had 10 cups of flour. 10 times 2 would give me 20 eggs. We had 100 cups of flour. 100 times 2 would give us 200 eggs. So this equation is called a function. It shows the connection between the two amounts, the cups and the eggs. Every time you have a number of cups, you can multiply it by 2 to get the number of eggs. All right, we're just going to try a couple more examples. And again, this is just an introduction, just to show you that we can show the connection in some different ways. Words, ratios, a table, a graph, and an equation. So there are different ways to show a function. Okay. Ooh, muffins. Let's talk muffins. You can get 2 muffins for $10. Sounds good to me. So let's write that as a ratio. You can get 2 muffins, so muffins on top, 2 muffins, dollars on the bottom, for $10. That shows a connection between muffins and dollars. But we can actually simplify this by dividing by 2. Divide by 2. 10 divided by 2 is 5. 2 divided by 2 is 1. So here we can actually use this ratio. 1 muffin for $5. Number of muffins, 1. How much is that going to cost? $5. We showed that using this ratio here, 1 to 5. All right, well, 2 muffins, and that's in the words here, 2 muffins is $10. Well, 3 muffins, if 1 muffin is $5, 2 is 10, 3 would be $15. These are expensive muffins. 4 muffins would be $20. All right. So let's use a graph here to show this connection between muffins. We'll put muffins on the bottom. Costs. We're not going to be able to go really high with this one because these numbers are increasing pretty quickly. So 1 muffin. Well, 0 muffins is $0. So I'm just going to put that here. That's 0 muffins for $0. 1 muffin would be $5. Okay, so I'll put a little point there. 2 muffins is $10, and really that's as far as we can go here. Because 3 muffins, if we look at the chart, 3 muffins is $15. That would be all the way up here. So we don't want to graph that because it's going to be a bit much. But I want you to notice something too here. This is a line right there. Another line, a diagonal line. Okay, let's try to write the equation here. We have number of muffins, which is M, and we have total cost, which is T. How do these connect to each other? Well, how do we get from the number of muffins to the cost? What can we do? 1 times 5 would give us 5. 2 times 5 would get us 10. 3 times 5 would get us 15. So it looks like we multiply the number of muffins by 5 to get the cost. So this is our number of muffins. If we multiply that, whatever number that is, whatever amount of muffins we get, if we multiply it by 5, that's going to give us the total cost. So we can see here, this shows the connection between the number of muffins and the total. This is called a function. It's like a special type of equation. So let's say we had 10 muffins. 10 times 5, the total cost would be 50. Let's say we had 12 muffins. 5 times 12, that would cost $60. All right. So we're going to do one more example like this to kind of show different ways that we can show connections. This one's the toughest one. Okay, this one's a little tough. This one says, bowling 2 games and shoe rental costs $5. Okay, so we have a ratio with games to cost. So we got it. This one's tricky because remember, there's the shoe rental involved. So if you bowl 2 games and pay for shoes, that costs $5. So that's going to be 2 games for $5. Now this is where this one's a little weird. This one gets a little tricky. Okay. Actually, I don't like that ratio. But we're not going to really use it that much. Number of games total cost. Number of games, total cost. Okay, so we can see here the table's already filled out for us. Let's do the graph first, then we'll think about how we can write the equation. So on the bottom, we're going to put games. And then on the side, we're going to put cost. Okay, so one game will cost $3. So one game, $3. Two games, it's going to be $5. So two games going up to $5. Three games, $7. So three games, $7. Four games, $9. So we pay for 4 games. It's going to cost us $9. All right, now here's the thing. Again, another line here. We got another diagonal line. This is the tough part with this one, because this is not like the others. How can we get from 1 to 3? Well, we could do times 3. However, it's got to work. It's got to be the same sort of rule, or it's called a function rule for each one. So if times 3 works here, it's got to work on the one below it. Well, 2 times 3 is not 5. 3 times 3 is not 9. Or I'm not 7. 4 times 3 is not 12. So times 3, or 4 times 3 is not 9. I'm sorry. It's hard to say that. And, that was kind of confusing, but it's not. 4 times 3 is 12, not 9. So this times 3 is not working. Okay? So how can we do this? It might be what's called a two-step function. Okay? So remember, this is the cost of the games and the shoes. And the shoes. So let's try this. What if we multiply by 2? And you might be thinking, well, if we multiply by 2, 2 times 1 is not 3. What if we multiply by 2 and then we add 1? 1 times 2 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 3 times 2 is 6, plus 1 is 7. So it's important that we do the same thing each time. 4 times 2 is 8 plus 1. So this is called a two-step function. To get from this the number of games to the total cost, we would multiply by 2 and then add 1. So this add 1 here, this is how much it would cost to rent the shoes. So it looks like each game is $2, plus you got to rent the shoes. So if you play 4 games of bowling, you don't rent the shoes each time. You just pay $1 right off the bat, right from the start, for the shoes. So this equation is going to look like this. We have G and we have T. What we have to do to G is multiply it by 2, so 2 times G, then we have to add 1, and that will give us the total cost. So let's take a look at this equation. This 2 is the cost of the games. This G is the number of games. So let's say we play 5 games. We would do 2 times 5. That would give us $10. But you also have to rent the shoes. So $10 plus 1 would give you 11. Now, this 1 is by itself because you only have to buy the shoes once. So if you play different number of games, that's going to change the cost. Any amount of games you play, though, you're still going to have to pay the $1 for the shoe rental. This is called a two-step function. The other ones were one-step functions because you only did do one thing to get from one number to the other. All right, so that was just an introduction. I just wanted to show you that you can show a function in a few different ways, like a table, graph, equation, and whatnot. So we're going to be practicing and working on some of these different ways of showing functions during the unit. And we're going to start with something called a ratio table, which is similar to the table here. All right, so that was our intro. If you have any questions, let me know. Hope you have a great day, though, and I will see you soon. Bye-bye.